In this video, we're going to talk about state variables. So far in the previous videos, we defined a transfer function as long as we have output, one input. Okay, but most of the systems are going to have more than one input and more than one output. If that's the case, to derive a transfer function, state variables method is easier to derive a transfer function if there are more than one input and one output. So state variable is nothing but it is a set of variables that are used to describe the mathematical state of a dynamic system. By using state variables, we can find the system future behavior. Okay, here in this video for state variables, I'm going to use x1, x2, x3 are the state variables. Those are basically representing I and V in electrical circuits. Depending upon the other system, mechanical system, those state variables could be like velocity, acceleration, direction, those things. Okay, now x dot of t, which is dx by dt, is nothing but state vector, and u of t is the input vector, y of t is the output vector. Now by using the state variables, I'm going to derive the state equation. That state equation is nothing but x dot equal to ax plus bu, y equal to cx plus du. That's the output equation. A is called system matrix, B is called input coupling matrix, C is output matrix, D is feed forward matrix. So a simple example I always use of a car. So here, if you take a car, it's the same system, but you can have different set of state variables. I can have different set of state variables depending upon my requirement. Say if you look into the car dashboard, you see the speed. That's one state variable, right? And you see the acceleration, okay, and fuel level, temperature of the engine. These are all the state variables for that given system. Okay, so you can tell instantly, I mean, it's a dynamic system, so you can tell what is the speed, you can tell what is the acceleration, what is the fuel level, temperature of the engine. These things are the state variables of the given system. Here is a simple example. We're going to find state equation, output equation for the given circuit. Okay, now the state variables in an electrical circuit is always depends upon the number of energy storage elements. Okay, so here I have one energy storage element, so we're going to end up having one state variable. Okay, so U as an input, Y as an output, R and L. Okay, so here he's asking about write down the state equation and output equation. So we're going to solve this in time domain basically. Okay, so let me write down two important points. So in any electrical circuit, number of state variables in a circuit is always equal to number of energy storage elements. So in this circuit, I have only one energy storage element, so I'm going to have only one state variable. Next important thing is always choose current passing through the inductor as one state variable. So whenever we are choosing state variables, always choose current passing through the inductor as a state variable, and if you have capacitor, then voltage drop across capacitor as another state variable. So here I have an inductor, so I'm going to choose current passing through the inductor as state variable. Okay, x1. So basically my x1 is nothing but current passing through the inductor, which is in amperes. So if you follow your textbook, most probably your textbook is going to choose x1 as I1. So now I'm going to write down the loop equation. Write loop equation. Okay, So my loop equation u equal to, so these are the open terminals, no current is passing through this. So u equal to r x1 plus, what is the voltage drop inductor? So if you look at the inductor, if you know the current passing through this, let me choose this as x1, then the voltage drop across this is L times dx1 by dt. So L times x1 dot. Okay, so plus L times x1 dot. Okay, now if you remember the state equation, it's nothing but x dot equal to ax plus bu. So all I need to do is write this down in terms of x1 dot. So L x1 dot equal to minus r x1 plus u. So x1 dot equal to minus r over L x1 plus 1 over L u. This is my state equation. Okay, now to write down the output equation, output equation is nothing but y equal to cx plus du. So here, can I say y is nothing but L x1 dot? Okay, because output y is nothing but the voltage drop across the inductor. I can say y equal to Lx1 dot. Lx1 dot I already have minus r x1 plus u. This is my output equation. Okay, so if I write it down in matrix format, if you remember, x dot equal to ax plus bu, y equal to cx plus du. Okay, so x dot, or here x1 dot equal to minus r over L x1 plus 1 over L u. So my A matrix is 1 by 1 matrix. I end up with minus r over L. My B matrix is also 1 by 1 matrix. It's 1 over L. And y equal to minus r times x1 plus u. So C equal to minus r1, D equal to 1. Those are the ABCD matrices. Now let me go with another example. Here the next example is I have RC circuit. Okay, so here is my U and output as Y, R and C. Okay, now as I mentioned, when you choose the state variables, we always choose current passing through the inductor or voltage drop across the capacitor. So here my x1 is the voltage drop across capacitor. So in the previous example, my x1 is current. In this example, x1 is voltage. So as I mentioned, x1 and x2, x3, I mean, if number of state variables are equal to number of energy storage elements in the circuit, here I have only one energy storage element, so I chose x1. So do I know the current passing through this? I don't know. So let me choose that as I. I'm going to apply KVL in loop. Apply KVL in the loop. So U equal to R times I plus x1. Okay, but to get the state equation, I want x1 dot equal to something. Okay, so I need to eliminate this I. Okay, we'll do that in a second. Now can I say the voltage drop across the capacitor x1 equal to, can I say 1 over c integral of I dt? That's the voltage drop across the capacitor. Okay, so can I say x1 dot is nothing but 1 over c times I, or I equal to cx1 dot. So I equal to c times x1 dot. Okay, I'm going to replace this I here. So U equal to R times RC times x1 dot plus x1. So x1 dot equal to minus 1 over RC x1 plus 1 over RC u. This is my state equation. Okay, output equation y equal to x1. That's my output equation. Okay, so state equation and output equation. Let me go with one more example in this video. It's RLC series circuit. Here is another example. In this example, he's asking us to find the state equation and output equation. When you have the circuit, definitely he will give you the input. U is always input, Y as an output. If you follow your textbook, I think that they chose different variables like Z as an input and Y as an output. So, but this is more standard. We always take U as an input, Y as an output. Okay, those two values are always given. Now you have to choose the state variables x1 and x2. So in this case, I have two state variables. One is current passing through the inductor and voltage drop across the capacitor. So number of state variables in a circuit equal to number of energy storage elements. So I have two energy storage elements, so I chose two state variables. Okay, now loop 1 apply KVL. Loop 1 apply KVL. So U equal to R times x1 plus L times x1 dot plus x2. Okay, so this is one of the state equation. Since we have two state variables, you will end up with two state equations though. So let me simplify this. If I simplify this, L times x1 dot equal to minus R x1 minus x2 plus U. So x1 dot equal to minus R over L x1 minus 1 over L x2 plus U. This is one state variable, state equation. Another state equation, can I say x2 is the voltage drop across the capacitor. Can I say x2 dot equal to, or can I say x2 equal to 1 over C integral of x1. Okay, so x1 is the current passing through that capacitor. So can I say x2 dot equal to 1 over C x1. This is my second state equation. Okay. Now the output equation y equal to x2. This is output equation. These two are the state equations. Now if I write it down in matrix format, x dot equal to, since there are two state variables, x1 dot and x2 dot equal to, I have a matrix, I'm going to write it down in matrix format, minus R over L minus 1 over L 1 over C. I don't have any x2 terms, so I'm going to put that as 0. Okay. x1 x2 plus B. Here I have one U term, so 1, there is no U term in the second one, so U. So this is matrix A, matrix B, and matrix C. So the output equation y equal to, I have only x2 in this case, so can I write this as 0 and 1, x1 and x2. So this is matrix C, and I don't have matrix D, so I can say 0 times U. So this is matrix D. Those are the ABCD matrices. Once we have ABCD matrices, it's easy for us to find the transfer function. So in this video we learned about state variables. So state variable method is easy for us to find the transfer function if there are more than one input and more than one output. Okay, and a state variable is nothing but let me try down the definition. State variable is nothing but it's set of variables that are used to describe the mathematical state of a dynamic system. And by using state variable, we can find the system feature behavior. So next video will solve an example with more than one input. Thank you.